Edexcel Core Pure, polar coordinates, parallel and perpendicular tangents to the initial line. So if we look at the tangents to this polar curve, there are many tangents to this curve, and if we think about the general points, such as this one, the tangent at that point is beyond the scope of the work that we're doing at the moment. However, if we look for tangents which are parallel to the initial line, such as this one here, or perpendicular to the initial line, such as this one here, then we can work out their equations. If we look at the tangent parallel to the initial line first, and look at its y coordinate, y has reached its maximum value. So as theta sweeps around this curve, y has reached its biggest value as theta changes. In other words, the rate at which y is changing at that point must be 0. If we look at this point here, x has reached its minimum value. So as theta goes round this curve, x has reached a point where it has reached its lowest value, and therefore the rate of change of x with respect to theta must be 0. So if you want tangents parallel to the initial line, you want dy by d theta 0, and those tangents perpendicular to the initial line, you want dx by d theta to be 0. So here we want to find the tangents to the polar curve r equals cos theta, which are parallel to the initial line. If we just quickly sketch this curve, when theta is 0, r is 1. When theta is pi by 2, r is back at 0. I could check some more points, but we should find that we are dealing with a circle. And we want the tangents parallel to the initial line. So there's one here that we are hoping to find, and there's one here which we are hoping to find. So we know that r equals cos theta, and we know if we're looking for tangents parallel to the initial line that we need to study dy by d theta is 0. We know that r is cos theta. We also know that y equals r sine theta. So these are the two equations we can use to investigate y. So y equals cos theta sine theta. Now we could differentiate this with a product rule, but it's much neater to use a double angle formula and turn it into a half sine 2 theta first. Now when we differentiate it just using a little chain rule, we get dy by d theta is cos 2 theta. And we want dy by d theta to be 0 because that's the condition for these parallel tangents. If cos 2 theta is 0, always try and solve for 2 theta before you look for theta. So if cos 2 theta is 0, then 2 theta will be pi by 2, 3 pi by 2, 5 pi by 2, and 7 pi by 2. So they are all the possible values for 2 theta. Bear in mind that 2 theta will be going from 0 all the way up to 4 pi radians. So they're all the possible values for 2 theta. But we're interested in theta, so that's pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. So they are all the possible values of theta in the range 0 up to 2 pi. On closer inspection though, if we look at 3 pi by 4, at 3 pi by 4, the cosine of 3 pi by 4 would be negative. So that would give us a negative value of r, and we don't consider negative distances from the origin, so I can dismiss that. And for the same reason, we don't want to look at 5 pi by 4 because that would give us a negative distance. So the thetas we're interested in are pi by 4 and 7 pi by 4. If we look at theta's pi by 4 first, then we know that y is cos theta sine theta, so y is cos pi by 4, 1 over root 2, sine pi by 4, 1 over root 2, which gives us y equals a half. If we look at theta is 7 pi by 4 now, we know that y is cos theta sine theta, so cos 7 pi by 4 is 1 over root 2, sine 7 pi by 4 will be minus 1 over root 2, and therefore we get y is minus a half. And we can see that it fits in nicely with the diagram. When theta's pi by 4, which is this line here, we should get y equals a half. So there's theta's pi by 4. And when theta's minus pi by 4, which is this line here, there's minus pi by 4, we should get y is minus 1 half. Just a little aside before we move on, if we were going to look at the tangents perpendicular to the initial line, so we want dx by d theta to be 0, and we know that x equals r cos theta, so x would be cos squared theta, and if we set that to 0, we would find we got theta 0 and theta is pi by 2, and that would give us x is 1 or x is 0. So they would be the tangents perpendicular to the initial line. So things to look out for these parallel tangents is to use r equals cos theta and y equals r sine theta, and together they give you y as a function of theta. That clever little use of the double angle formula makes it much easier to differentiate, and we need to pick out all the values of theta between 0 and 2 pi. We could dismiss these two values of theta because they gave us negative distances, and we're really interested in the positive distances. And by subbing pi by 4 and 7 pi by 4 back into the y equations, we were able to find the equations of those parallel tangents. That brings us to the end of polar coordinates.